Problem 10 says use the values of the given definite integrals to determine the quantities below. So we have the integral of 1 to 7, 2f of x minus 5g of x dx. So when I'm going to do a problem involving substitution, I like to rewrite it so that it looks exactly like the pieces I want to substitute, just so I can triple check that I'm like plugging the numbers in all the correct places. So the first thing that I would like to do, it's a little bit of extra step from the key, is I would say, well, the integral of 2f of x, that's just the same thing as 2 times the integral from 1 to 7 of f of x dx. Then minus 5 times the integral from 1 to 7 of g of x dx. So f of x dx, we were given right here as negative 8. G of x from 1 to 7 was given here. So you need to make sure that the bounds on the integral you were given match the bounds in your formula. So now I can simply make my substitution. 2 times negative 8 minus 5 times 9, and this is negative 19 minus, negative 16 minus, we'll do that so you can see it, minus 45, which is negative 61. Part B says, well, what is the integral from 1 to 3 of f of x dx? So notice none of my integrals up here go from 1 to 3, right? But I have two integrals that are talking about f of x dx. So I'm going to use a number line just to make sure that I get this right. So we know the integral from 1 to 7. We're looking for the integral of 1 to 3. So I don't know what this is. I was told the integral from 3 to 7 at the top is 12. And we were told that the integral from 1 to 7 is negative 8. So there's a couple different ways we can think about this. We know that the sum of these two integrals should equal the total. So our unknown plus 12 should equal negative 8. So that means question mark is equal to negative 20. You could also split this up as the integral from 1 to 3 plus the integral from 3 to 7 equals the integral from 1 to 7, and that's just a lot of integrals to write out, but this is enough work that you could justify that out. The last one kind of throws people for a loop sometimes because we throw some extra variables in there. This is actually a really straightforward problem when you see how to do it. So we've got the integral from 1 to 7 of g of t, which we know how to do, but then we added on an extra expression of minus t squared. So this is where what I did in part A I think is quite helpful. So first I'm going to rewrite the problem and I'm going to separate the stuff I know from the stuff I don't. So this is the integral from 1 to 7 of g of t dt minus the integral from 1 to 7 of t squared dt. Well, this is a known value. I know this is 9, so I can just substitute 9. This is an integral I can very easily calculate. So the antiderivative is going to be t cubed over 3. I'm going to evaluate that from 1 to 7. So I get 9 minus 7 cubed over 3 minus 1 cubed over 3. And this equals 9 minus 343 over 3. This minus minus becomes a plus. And so it is perfectly okay to stop back here, but if you want to keep going, This will end up adding up to 105 after you get a common denominator and add, but I would just stop here. There's no reason to keep going.